everyone. Myself Professor Shilpa Patil, working as an assistant professor in the Department of EEE, SAVI with the Institute of Technology, Bangalore. In this video lecture, we are going to discuss about a simplification of a Boolean expression using K-map technique. In a digital system, we always wanted to have a circuit which is having very less number of gates, compact in size, and which in turn reduces the cost of the circuit. In order to reduce the number of gates in a circuit, so we need to simplify the Boolean expression of the circuit. One of the common method we will use to simplify the Boolean expression is using Boolean laws. I think in basic electronics you already studied how to solve the simplify the given Boolean expression using Boolean laws. That method is having certain limitations. The first one is that is completely depends upon the human ability and we will not get an unique solution. And second one is as the number of variables increases, the complexity increases. For example, if the expression has a three variables, we will simplify it easily compared to the expression which has a variables of 5 or 6. So in order to overcome these limitations, we will use other methods to simplify a given Boolean expression. In that, K-map is also one method which will solve the Boolean expression using a schematic way. So we have other methods also like Cuny-Makliski method and map entered variable method, which we are going to discuss it in the further lectures. So in a K-map, how we are simplifying means first we will draw the cells based on the number of variables. Then we will fill those cells by using the truth table of the circuit. Then we will simplify it using certain rules. Right? The number of cells in a K-map is equal to the 2 to the power n, where n is the number of variables in the expression. Suppose if I have a two variables, then I need four cells to simplify the expression, right? So we will draw the four cells like this. One variable I will take it on the row side and another variable I'll take it on the column side. We will have a two options because if there is a single variable, I have two input possibilities 0 and 1. So I have taken two rows and even B will have a two input possibilities 0 and 1. So two columns, right? Similarly, if you have a three variables, then we have to use a 8 cell K map in order to simplify the expression, right? So this is an 8 cell K map. So we have a two rows, right? So we will take one variable here so that it has a two possibilities of input 0 and 1. Then we will take two variables on the column side because the four possibilities of the input that is 0 0 0 1 1 0 and 1 1, right? And similarly if you have a four variables, then you need to use a 16 cell K map. So we will use two variables in a rows side and two variables on a column side. Now, so this is how we will decide a number of cells in order to simplify an expression based on the number of variables. So if you have a five variables, then we need to use a 32 cells K map, right? So now we will come to know that how many cells we need to use. Now we will discuss how to number these cells, right? I wanted to enter the cells using the truth table. Before that, I should number the cells, right? So numbering of the cells is done like this. If we have a two variables, so we will use a four cell K map, right? Then we will take one variable to the rows and another one on a column side. So each will have a two possibilities of input 0 and 1. So we'll take this as 0, 1, 0, 1. Now, so for the first cell, okay, so for the first cell, what is the values of A and B? Both are 0, 0. So the cell number is 0. Similarly, for a second cell, next cell, right? What is the values of A and B? 0, 1. So we have written a cell number as 1 on the right corner of the cell, right? Similarly, for the below second row, first column, the A and B values is 1, 0. So it is 2. Then 1, 1. So then it is cell number 3. Okay. Similarly, when we use a three variables, right? So one variable we will take it on row side and another variable we will take it on the column side, right? So we have two possibilities, means two rows, 0, 1, and we have four columns, right? That is 0, 0, 0, 1, 1, 1, 1, 0, right? Why we have taken 1, 1 and then 1, 0? In the beginning, I already told you, right? In a K map, we will simplify based on the single bit change. The adjacent cell should be a single bit change. So that's why, so 0, 1 and 1, 1 are the single bit change. So that's why we are using it in the adjacent columns. So again, we will follow the same procedure to number the cells, right? On the first row, first column, all are 0, 0. So 0 cell, then it is 0, 0, 1. So cell number 1. Then for third, it is 0, 1, 1. So cell number 3. Then 0, 1, 0, 2. Like again 4, 5, 7, 6. Right? So that's why we will get a cell numbers like 0, 1, 3, 2, 4, 5, 7, 6 in order to have a adjacent cells with a single bit change, right? Similarly, we will have a four variable K map, 16 cells, right? So two variables means four columns and four rows, right? So it's the same way we will numbering, right? So each cell check the all the input variables, then get a decimal value of it, and that will be your cell number, right? So we will get a numbers like this, that is 0, 1, 2, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10, right? So always the adjacent cells in the K map are single bit change. You can check any cells over here. So those are single bit change. That's why the simplification will be done, right? So now we will go to the steps. I already told you once we enter the K map using truth table, we will solve the Boolean expression using certain expression. Then we will go for POS expression. So the first step is, so based on the number of variables, you have to plot the K-map. That is a common step for all the K-map problem, right? Then you have to place a ones in those cells corresponding to the ones in an SOP expression. Okay, so sometimes they will give you a truth table or sometimes they may give you a expression. Okay, so based on the truth table or expression, you have to fill the ones in a corresponding cells. Then in the remaining cells, you have to place the zeros. Once you place the ones and zeros in the K map, then we will start grouping the cells. Okay, so we will always group adjacent cells which has a ones because they are differ by a single literal, right? So first we will check for the adjacent ones which are not adjacent to any other ones, right? They are called as an isolated ones. So first we will find out the isolated ones. Then We will check for the ones which are adjacent to only one another one. We will encircle such pairs. Then we will search for a quads and octets of adjacent ones. Then we will group the octets and the quads and make sure that there should be a minimum number of groups. Then write down the simplified expression for all the groups. Then by summing the product terms of all the groups, we will get an simplified expression by using an K-map. So this is the steps to be followed while solving the expression, right? So we'll go for the first problem, right? So this is a first problem. Minimize the expression using K-map. F of ABC is equals to summation of M 0, 1, 4, 7. So summation of M means this is an SOP expression, right? So we have three variables here. How many variables? Three variables A, B, C, right? So we will solve using K-map. First, we have three variables. So I have to plot 8 cell K-map. 2 to the power 3 is 8 cell K-map, right? So what are the variables is given in the problem? A, B, C. So I will take A, B, C, right? A for the rows and B for the columns, right? Then we will start numbering 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Since we are doing with a SOP expression, in an SOP, 0 means complemented, 1 means uncomplemented, right? So that I can write here A is 0 means it is A bar and A is 1 means it is A. Then 0, 0 means it is B bar, C bar, B bar, C, B, C and B, C bar, right? So why I have written here means this will be helpful for us while writing the simplified expression. Okay, then we will place the cell numbers here 0, 1, 3, 2, 4, 5, 7, 6, right? Now, so this is the first step where we have plotted a K-map based on the number of variables. Now we will place the ones. Okay, so what is an expression is given? Summation of M is equals to 0, 1, 4, 7. Okay, so we will place ones in the cell number 0, 1, 4, 7. Okay, so in the expression they have given 0, 1, 4, 7. So we will fill ones in the those corresponding cells. In the remaining cells, we need to fill the zeros. Okay, so this is a first step. So we plotted the K map and we placed the ones and zeros. Now we have to start for the grouping. Okay, so what is the next step? We have to find out the isolated ones. Okay, so here just see the cell number 7. Okay, so what are its adjacent cells? 3, 6, 5 are the adjacent cells to the 7. But in all those three, it doesn't have 1. So this is a one which doesn't have any adjacent ones. So we call this as an isolated one. So I will group this isolated one, right? Then check for 0 and 1, right? So 0 and 1 are a pair adjacent to each other. So I will make a pair. Similarly, I have 0 and 4 also, right? So any other ones left out without any grouping? Right, no. That's so that is the end of the grouping. Now we have to write the simplified expression, right? So we will write an expression for each group. First, I'll write an expression for this isolated one. Okay, so for that group, search for the variables in a row wise and in a column wise. First go for the row wise. For the cell number 7, what is a variable we have? A. Then go in a column wise. What are the variables you have? B, C. So what is the expression for that group is A, B, C. Right? Similarly, we will write a simplified expression for 0, 4 group. Okay, right. For 0, 4 grouping, just check it. For 0, you have A bar, and for 4, you have A. So A is changing. You should not take that variable, which is not changing. For 0, 4, B bar and C bar, right? So we will take a B bar and C bar is an expression. Similarly, write an expression for one more group. So for 0, 1, if I go for row wise, it is A bar. And when I check for 0, 1 in a column wise, I have B bar. But in for 0 it is C bar, and for 1 it is C. So it is changing. So what I should take here? A bar and B bar. Right? So we have three product terms. Right? By summing all the three product terms, that is nothing but your simplified expression. So that is okay. Let us take a second example. Minimize the expression using K-map. F of ABC is equals to summation of M 2, 3, 4, 6, 7. Okay. So again we have three variables. So I need 8 cell K-map. Right. So I have plotted 8 cell K-map. We have three variables A, B, C. So we'll take A, B, C like this. Then again 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Right? So we will write the literal for each term here. So this is A bar, A, B bar, C bar, B bar, C, B, C, B, C bar. We will write the cell numbers. Okay, right. Now, so what is it given there? Summation of M 2, 3, 4, 6, 7. It is an SOP expression. So we will fill ones in 2, 3, 4, 6, 7. In remaining cells, we will fill the zeros, right? So I have placed ones in 2, 3, 4, 6, 7. In remaining cells, I have placed the zeros. Now we will group the cells. Okay. Just observe the cell number 4. Okay. So what are the adjacent cells to the cell number 4? It is 5, 0 and 6. Okay. In 0 and 5, we don't have any ones. So I have to group that 4 with a cell number 6 as a pair. Right. So we'll group 4 and 6. Then we have a quad here, 3, 2, 7, 6. Okay, so we will write an expression. First, I will write an expression for a pair 6. Just see on the row side, it is A, and when you see on the column side, it is B bar and B for cell number 4 and 6. B bar and B, so I should not take B here. Then what is C bar and C bar, right? So it is A, C bar. Okay. Similarly, what is an expression for quad? So if I see the row wise, A bar A is changing. Then see in the column wise, so it is B, B, C, C bar. So C is changing, so only B. So what is the expression for this is B. So sum the product terms, that is your simplified expression for the given problem. That is B plus A, C bar. Right? So we'll take another example here. Right? So minimize a given expression f of wxyz summation of m 2, 4, 5, 9, 12, 30. Right? So how many variables are here? 4 variables. So I have to take how many cells came up? 2 to the power 4 is 16. So I will plot a 16 cell came up here. Right? 2 variables on a row wise and 2 variables on a column wise. Right? So now I will place the input combination 0, 0, 0, 1, 1011, then 00011110. So again, this is an SOP expression. We will write a literals, right? It is y bar, z bar, y bar, z, y, z bar, y, z. Similarly here, like this, okay? W bar, x bar, w bar, x, w x, w x bar, okay? So we will write the cell numbers, so which is common for every K-map problem, right? Now we will place the ones, right, in a corresponding cells. So what are the cells you have there? 2, 4, 5, 9, 12, 13. So in remaining cells you need to fill the zeros, right? So 0, 1, 2, 3, I have filled the zeros and ones. So in 2, 4, 5, 9, 12, 13, I have filled ones. In remaining cells I have filled the zeros. Okay. Now we will start grouping. Okay. So just observe the cell number 2, cell number 2, right? What are the adjacent to cells to the cell number 2? 3, 6, 10 and 0, right? So cell number 2 adjacent cells are 3, 6, 10, 0. In all the cells we don't have 1, so this is an isolated one, right? Then see the cell number 9, so it is adjacent with what? 13. So I will pair the 9 and 13. Then I have a quad here for 4, 5, 12, 13. Okay, so we'll write an expression for isolated one. What is an expression? It is w bar, x bar, y, z bar. Then what is an expression for 13 and 9? It is w, y bar, z. And similarly, the expression for quad is, what is an expression? W is changing. W bar and W is changing. So I should take X. Then on the column side, Y bar, Y bar. I should take Y bar and Z is changing, right? So it is X, Y bar. Okay. So sum the all the product terms here. So that is your simplified expression using K-map. Okay. Right. Similarly, we will take one more problem. YZ summation of M 0, 2, 4, 5, 6, 8, 9, 10, 15. Okay, again 4 variables. So we will take a 4 variable K map here. Right, we will place a 0, 1, 1, 0, 1, 1. Then we will write a literals. Okay, so then we will place the cell numbers. Okay, then after placing the cell numbers, we have to place the ones corresponding to the equation. So in cell number 0, 2, 4, 5, 6, 8, 9, 10, 15, we have to place ones. In remaining cells, we have to place the zeros, right? We will place like this. Okay, so I have placed the ones in 2, 4, 5, 6, 8, 9, 10, 15, and in remaining cells, I have placed the zeros. Now we will start grouping. Okay, just see the cell number 15 here. Okay, so your 15 is adjacent to what? 7, 13, 11 and 14. In all the adjacent cells, it doesn't have a 1, so 15 is an isolated one, right? Then see the cell number 5. Okay, your cell number 5 is adjacent to 1, 7, 13 and 4. So it has a 1 in the 4, so I will make a pair of 5 and 4, right? Similarly, a cell number 9. So in cell number 9, it is adjacent to 8. So we have a pair here 8 and 9. Okay. Then we have a quad here, right? So 2, 6, 0, 4, right? Then check for cell number 10. Okay. Your 10 is adjacent to what? 2, 0, 2 is adjacent with 0 and 0 is adjacent with 8. So we have a quad over here. So it is 0, 2, 8 and 10 is also a quad. Okay, we will write an expression one by one here. So first I will write an expression for isolated one, that is wxyz. Then for group pair 8, 9, we will get an expression of w x bar y bar. Then for 4, 5, it is w bar x y. Then for a quad, for that is 0, 4, 2, 6 quad, w bar z bar. Then for the 0, 2, 8, 10, it is x bar z bar. So write all the product terms. So that is your simplified expression. Okay, right. So take down one more problem now. Okay, so take down an example. Minimize the expression using K-map. F of A, B, C, D is equals to A bar, B bar, C plus AD plus BD bar plus CD bar plus AC bar. Right? So just observe this equation. This equation is not in a canonical form. Means this expression is not in a canonical form. Okay, so we have to bring this in a canonical form, then we can apply the K-map, right? Remember, while solving a K-map or using a Cuny-Makliski method, the expression should be in a canonical form. Okay, right? So we will first bring this in a canonical form. Okay, so first find out the missing literal, then and with a literal and it's complemented, right? Then simplify that one and we will get an canonical form like this. Okay, so in lecture 1 we have solved so many problems how to convert an boolean expression into a canonical form. The same steps you have to follow to get this canonical form expression, right? So again we have a 4 variables here, so I will plot a 4 variable k map. Okay, right? So the procedure is same, only thing here you should bring that expression in a canonical form, right? So we will solve this using k map now, right? So again we will take the variables and cell numbers. Okay, right? So again, what I have got here in a canonical form 2, 3, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15. In those cells, I should fill ones. In remaining cells, I will place the zeros. Okay, right? So the grouping is done same way, right? So we'll have one quad here, that is 3, 2, 11, 10. Okay, then we have another quad 4, 12, 6, 14. Right? Then we have an octet, right? So where you have an octet 8, 9, 11, 10, 11, 12, 13, 14, 15 is an octet. Okay, right? And we will write a expressions for sorry, each group, right? Then that is your simplified expression for the given problem, right? Okay, so this is how we are solving a SOP expression using a K-map, right? Then we will move on to simplification of a POS expression using K-map, right? So here the steps, grouping, everything same as a SOP expression, but only thing you have to place zeros in those cells corresponding to the zeros in the POS expression. And in remaining cells, you have to place ones, right? And here you have to group as zeros. How you were grouping ones in an SOP expression, you have to group zeros in the POS expression, right? So what is the first step, students? You have to plot the K map based on the number of variables. Then you have to place the zeros corresponding to the uh, POS expression, and in remaining cells you have to place the ones, right? First search for an isolated zeros, okay? Then search for a pairs, okay? The next step, we'll check for the quads and octets, okay? Then write the simplified expression for all the groups, then and the those sum terms, okay? That is your simplified POS expression, right? So we will take an example here, right? Minimize a given expression using K map. Y is equals to A plus C bar ANDed with A bar plus B bar plus C bar ANDed with B plus C. Right, students? Okay. Here, this is an POS expression, and this expression is not in a canonical form. Okay. So how many variables are there here? Three variables, right? But all the sum terms is not having all the variables. So I should bring this in a canonical form, right? So how to bring this in a canonical form, right? So we will find the missing variable. So in a first term, B was missing, so I ORed with B plus B bar. And in second sum term, we have all the variables, that is fine. But in a third sum term, A was missing, so I ORed with A and it with A bar. Okay, simplified using Boolean, using distributive law. Then we will write an min term. Then we will get an canonical form as f of ABC is equals to pi of m 0, 1, 3, 4, 7. Okay, right. So once you get a canonical form, you have to plot the K map. Okay, so here, since we have three variables, I will plot 8 cell K map. Okay, right. So the same way I'll take A, B, C here. So 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, right? So this is an POS expression. In POS expression, 0 means complemented, 1 means uncomplemented, right? So how we will write here? So this is your A, right? And this is your A bar, right? So similarly in the columns, this is B plus C, and this is B plus C bar, B bar plus C bar, then B bar plus C. Okay, right? We will write the cell numbers as usual, right? Now, so corresponding to your POS expression, I need to fill the cells with the zeros, right? So in cell number 0, 1, 3, 4, 7, I should fill zeros. In remaining cells, I should fill ones. Okay, right? I have filled the zeros, and in remaining cells, I should fill the ones. Now we should start grouping. Okay, so we have to group zeros here, right? So whether your 7 is adjacent with 3, so I'll make a pair of 3 and 7. Then I'll make a pair of 0 and 1. Then I'll make a pair of 0 and 4. Okay, we will write a sum term for each group, right? So for 0, 1, it is A plus B, right? Then for 0, 4, it is B plus C, right? Then similarly for 3, 7, it is B bar plus C bar. Okay, and the sum terms, that will be your simplified expression for the given problem.